Hey people, welcome back to Cybernetics. So, in today's video, we'll be doing corner detection in images. So, which will basically point out all the corners that are there in the image. We'll be doing with the most basic image, that is chessboard. So, first, obviously, we'll import the libraries numpy and CV2. Now, we use imread function. We don't use video capture function. You can also use video capture function, but if you don't know it, you can refer my previous videos. So to get the image, we use imread function and we pass the path of the image in its arguments. Okay, so moving ahead, now the step that we're going to do is a really important one and will be used a lot of times in further projects, which is to convert that image into grayscale. The first question after hearing this would be why? Well, I'm here to explain that. The color detection algorithm that we'll be using uses intensity of color to detect corners. So it's easier for the algorithm when the image is in grayscale. We use the following command to turn it into grayscale. That is gray is equal to cv2.cvt color, and in its first arguments we pass the image, and its second arguments we pass cv2.color underscore bgr to gray. And the name of the algorithm is Shitomasi. And function's name is goodfeaturestotrack. And in its first arguments we pass the source image, and in second arguments we pass a number of best corners. So there might be any number of corners that the algorithm might make out, but if you want it totally depends on your requirement. If you want 10 best corners out of them, it'll show you the 10 best corners. And the third argument is quality, minimum quality, or you have a range of 0 to 1. You can write them in decimal 0.5, 0.4. I'll write 0.5. And then the fourth argument is minimum Euclidean distance. That is all corners. There might be so many corners that it might detect when two points collide. So you have to specify some distance. So that distance will be excluded, and whatever corners that come inside that distance will be excluded, and it'll give you the rest of the corners. Now we get those corners as floating variables, so we convert them into integer using np.int of 0. And these values are multi-dimensional, so we need to remove them and make it a single array so that we can print the we can point out the corners in the image. So we use a for loop there, and I'll print and show you the values of the corner that we get. The error here is that I passed image. I should have passed gray because I've already told that the algorithm uses grayscale image. Let's change it to gray. So we basically need to get the XY value. That's how we make out the position where we have to point the corners. And so xy is equal to corner dot travel is the function that is used to flatten the array. And by flattening the array, I mean turning a multidimensional array into a single dimensional array. So in this example, I'll be showing you 1, 2, 3, 4, 5, 6 as two separate arrays that are in a separate array inside a main array. Now when we flatten it, we get a single array with 1, 2, 3, 4, 5, 6. So cv2.circle function, I've explained how to use this before. And then cv2.imshow, wait key, destroy all windows as usual. In every application we use it. And then we get the output.